Hello YouTube. So it's kind of been a while since the last video on this. You can see, I don't even know if you recognize it anymore. This is the wheeled robot that I've been working on. And yeah, the last video I made on this was 5 months ago, and there's a very good reason why. Because the last time I worked on it was 5 months ago. Until a couple of days ago when I decided to finish all of the electronics in this robot. You could see I used some electronics. These should be familiar. This is the same Arduino I've used in many projects before. It has 4 sets of 2 relays. You can see right here. I probably should open up this top piece and show you everything beneath, but these holes aren't exactly lined up, so it's kind of a tight squeeze, so I wouldn't really want to do that. You could see that it's a set of 2 relays. You see these 2 relays correspond to this motor down here, right here. And these 2 relays up here correspond to that motor down there, etc., for all 4 wheels. And basically it's set up like an H-bridge. So it's wired in a way so when this relay turns on, it goes one way, and when the other relay turns on, it goes the other way. When both relays are on, or when neither relays are on, the motor stays still. And it's like that for all of these wheels. You can see on the breadboard, all the control wires from the relays are coming out. It looks pretty complicated, but that's just because it's on a breadboard. All the positive wires are connected together for the relays, and they're wired in such a way where both of these motors are wired together and both of these motors are wired together. So these 2 motors can go forward and backwards. These 2 can go forwards and backwards, but they are wired together for simplicity purposes in programming. And well, because why would you ever want this motor to go one way and this motor to go the other way? Or even if you wanted this motor to turn and this motor to stay still, it's not a loose bearing. There's still the gears here. So basically, every time you would want to make this move, both of these motors would have to go this way, or both of these motors would have to go this way. You could have it so it can turn by just these 2 motors going this way and these 2 motors not going this way. It can go backwards by all these motors going this way. But in no circumstance would the direction of this motor conflict with the direction of this motor, and the same for these 2. So I wired them together. In fact, you might be able to wire both of them to the same set of relays, but don't do that because you would have amperage problems, maybe. Well, these relays are pretty high amperage, so you might be fine, but I decided against that. Aside from that, there is the Arduino, which controls it. Right, I'll show you the program later in this video, but right now it's programmed so that it'll have all the motors go this way or this way, whatever it is, stop for a few seconds and then continue. And you could see that the Arduino has a USB cable and it's going to this 12-volt cigarette lighter port. This is actually, I bought this at Walmart. It was actually for my solar panels, if you've seen that. I have since taken all those down, but this is converts it to 5 volts. So what you get is that all of these motors are powered by 12 volts. So these are 18-volt drill motors, so if you power them by 12 volts, it'll still move just fine. And the 12 volts will convert to 5 volts, which will power the Arduino, and the Arduino will power all the control circuitry going into the relays and all of that. And that's how that works. So you could power everything by 12 volts. And that is kind of important because you just have one place to plug it in. So now I think what we should do is a little demonstration of how it's working. So we have a problem kind of right now, and that problem is that I don't really have a battery for this. And okay, fine, I can power it with a computer power supply. Yeah, that works just fine. There you go. But when I do that, keep in mind that I'm powering 4 of these motors, and these are cordless drill motors. So basically what this is akin to doing is powering 4 cordless drill motors at near full power all at once with, and we also have relays too. So we are also powering 4 cordless drill motors all at once at full power, and 4 electromagnets for these relays all at once at full power. So this does consume a lot of amperage, and we would need a pretty beefy battery for this. I have some ideas on how the battery should work, but the important part is we don't have that right now. I do have that lead acid battery, like a big lead acid battery you put in a UPS. I tested that a couple times. It appears to work better than anything else that I've tried, but the battery's dead right now. So we're going to use a computer power supply. And because that does not provide enough amperage, we will only be testing a single motor, which is this motor right here. You could see, just disconnect all these motors and they'll turn off. That's one thing that I did use a lot was these Anderson power pole connectors. They're on these connecting to the motors, and if you look inside here, there are also Anderson power pole connectors connecting all the relays to the main power line, which are these 2 clips right here. So let's turn this on and see how it works. So it is, put it on 12 volts. Yeah, I should get an actual power supply, but this actually does work pretty well for what I've used it for. So that's the 12 volt port. Let's turn it on. Actually, let's unplug that. So turn it on. So it's on right now, and you can see it's not doing anything. That's one key thing about the relays, is that you wire it so that when both of the relays are off, it doesn't move. That's important because you can wire it however you want. You could wire it so when both of the relays are off, it moves in either direction. But let's not do that. So when I plug this USB into here, the Arduino will turn on, and that will trigger this relay, which will cause this motor to move in pulsations. So 1, 2, 3, let's go. You get the point. One thing that you see is it kind of is pretty violent in that way. That goes zzz, stop, zzz, stop, zzz, stop. That's because we're using relays and not PWM, which would make it smoother. But those motor controllers are more expensive, so that is why we are not using them here. Alright, so the electronics are basically figured out. So theoretically, let's turn this off. So theoretically, if I had a good power source, I could have this robot move this way, and then stop for a second, move this way, and stop for a second. That's the program, if you were so curious. But that's what it does. So yeah, it can do that. I mean, a remote control car can do that. That's not that impressive. It just kind of proves it can move. So I'm probably going to have to add something for this to actually do. One thing that I've been thinking was maybe get a remote control for like an Xbox controller and try to make it move along with that. And then I would also put ultrasonic sensors on either of these corners so that it could avoid obstacles. And then maybe I could combine it together where it is remote control up until the point where it will not run into an obstacle. Other than that, I could probably add a robot arm on the top of it. You could see there's very convenient mounting ports. I could make something out of aluminum, just stick it here and have an arm, which would consume more power. So I really need to think about that battery. That's the main concern for right now. Also, I probably need to make a better program for it other than to move and stop and move and stop. I haven't even programmed it to go in the opposite direction. So I need to learn more about that. I'll see you in the next video, whenever that is. Probably I'll make a video when I charge up the batteries, and then we'll see it go full direction. So this is your monthly update of whatever I'm doing right now.